The M60 looked like a machine gun stripped to its job. It weighed 23 pounds empty. It used a 22-inch barrel and fed from a disintegrating belt of 7.62mm rounds. Yet it reached the world as two different guns. It was built for one honest purpose: to replace a whole shelf of Browning machine guns with a single weapon. A gunner carried the gun and a belt across his chest. An assistant gunner carried the spare barrel and more ammunition. A door gunner hung it from a bungee cord in an open helicopter. A raider cut its barrel down for close work. That modest requirement produced a vast program. Factories stamped it out of sheet metal, more than 250,000 of them, in plants better known for other peacetime work. The gun escaped its manual. It rode helicopters, went up rivers, and reached a movie screen in the hands of a star firing it one-handed. It gave a squad firepower it had never held. It took that back in weight, in heat, and in constant repair. That last exchange is the whole story. The M60 was neither the light rifle-caliber gun of the movies, nor the fixed, water-cooled Browning it was built to retire. It occupied the space between them. It was asked to be a bipod gun and a tripod gun, a jungle weapon and a helicopter weapon, a squad's automatic and a company's base of fire. Every role added something. Every role took something away. The gun carried two reputations at once, and they never matched. On film, it was invincible. One man walked forward, a belt swinging, and nothing stopped him. In the field, it was a shared burden that 3 or 4 men fed, cleaned, wired together, and cursed. The famous gun and the working gun stood side by side for 40 years. They were the same steel and the same drawings. They were not the same weapon. The two reputations never met. One was written by men who had never carried the gun, and it showed the weapon at its most flattering: endless ammunition and no recoil. The other was written by men who carried nothing else all day, and it showed the weapon at its most demanding: 23 pounds before a belt was loaded, a barrel that needed changing and no handle to change it by, a gas system held together with wire. Both reputations were built on the same gun. Neither was a lie. The screen kept the firepower and cut the cost. The field kept the cost and earned the firepower. To understand the M60 is to hold those two versions in one hand and refuse to drop either. How do you weigh a machine the screen made immortal against the men who carried it and could not wait to set it down? That question runs under everything that follows. It cannot be answered with the cyclic rate or the muzzle velocity alone. It has to be answered the way the gun was actually lived, as a set of trade-offs, each one paid for on somebody's back. The answer would travel a long way to be found. It would move from arsenal workbenches to sheet metal stamping lines, from Vietnamese rice paddies to open helicopter doors, from a raider's hacksaw to a movie star's hip, from the armies of 50 nations to the trials that finally retired it. It began, though, with a problem that had nothing to do with fame and everything to do with weight. Chapter 1. The gun zoo the Army could not afford to keep. The American infantry squad left the Second World War with too many machine guns and not one right one. Every gap those guns left behind was a gap a soldier's back had to fill. The problem was not a shortage of firepower, it was the shape of it. A rifle company carried the Browning family for its sustained fire. The Meter's 1917 was water-cooled and belt-fed, accurate and tireless, and it weighed more than 40 pounds before the tripod, the water can, and the ammunition were counted. The Meter's 1919 traded the water jacket for air cooling and came down to roughly 30 pounds with its mount, still a crew-served weapon that stayed where it was set. These guns held ground. They did not move with the assault. For the moving fight, the squad had the Browning automatic rifle. The weapon fired the same .30 caliber cartridge and weighed around 16 to 20 pounds depending on the model and its bipod. That weight was manageable. Its magazine was not. The gun fed from a box holding 20 rounds. A gunner emptied it in a few seconds of automatic fire and then stopped to reload. The Browning automatic rifle could march with the rifleman. It could not pour out fire the way a belt-fed gun could. That was the gap. On one side sat heavy belt-fed guns that never ran dry but never advanced. On the other sat a light automatic that advanced but ran dry in seconds. Between them was the weapon the Army did not have. One gun that could do both jobs: feed from a belt, move with the squad on a bipod, and lock onto a tripod for sustained fire when the squad dug in. The Germans had already built that gun. The Meter's G34 and then the Meter's G42 worked from a single design across every role. Mounted on a bipod, it was a squad weapon. Set on a tripod, it became a company's base of fire. It fed from belts. It changed barrels in seconds. American soldiers had met it across the width of 2 continents, and they had learned what a true, general-purpose machine gun could do to men in the open. That lesson had a sound. The Meter's G42 fired at roughly 1,200 rounds per minute, a rate so high the individual shots blurred into a tearing note that veterans never forgot. The rate was terrifying, and it was also expensive. At 1,200 rounds a minute, a gun devoured ammunition and burned through barrels, and a crew could not always carry what the weapon wanted to eat. The German design proved the concept of the universal gun. It also proved that raw speed carried its own bill. The American requirement, then, was not to copy the sound. It was to copy the idea and correct the excess. The Army wanted one belt-fed 7.62mm machine gun, light enough to carry forward on a bipod, sturdy enough to sustain fire on a mount, fitted with a quick-change barrel, and firing at a rate a crew could actually feed. The target weight was set at 18 pounds. That number was a promise to the men who would carry it. It would not survive contact with the design. The gap the new gun was meant to fill was measured in bodies and loads. A Browning crew moved its weapon in pieces. One man took the gun. One took the tripod. Others carried the ammunition in steel cans and the spare water for the older guns. The system worked, and it was slow, and it tied a heavy weapon to a fixed position while the rifles went forward without it. A Browning automatic rifleman had the opposite problem. He kept up with the advance, and then found himself thumbing a fresh 20-round box into the gun while the enemy fire he was supposed to suppress kept coming. Those two failures defined the whole requirement. A crew-served gun that could not advance left the assault without heavy fire. A squad automatic that ran dry left the suppression unfinished. The Army needed one weapon that erased both problems at once, and it needed that weapon to weigh what a man could carry all day. That is the emotional core of the entire story. The M60 was not conceived as a hero. It was conceived as a solution to a carrying problem, an answer to the question of how a squad could keep belt-fed fire moving with it across ground. Every later argument about the gun, its weight, its barrel, its reliability, its fame, traces back to that first modest goal. The gun was supposed to lighten the load and unify the arsenal. Whether it did is the argument that follows. The Korean War had sharpened the lesson the Second World War taught. In the cold and the mountains, American infantry again split their automatic fire between weapons that did different halves of the same job. The Browning automatic rifleman was the most important man in his squad and the most quickly out of ammunition. The machine gun crews held their ground with belt-fed Brownings that could not follow a moving attack across broken terrain. The pattern repeated because the tools had not changed. The gap the war had exposed was still open when the shooting stopped. Behind every part of that gap stood a man and a load. A Browning crew in the field was a small logistics operation, one soldier under the gun, another under the tripod, others bent beneath steel cans of linked ammunition. Setting the weapon up took time. Moving it took longer. A Browning automatic rifleman carried a lighter burden and a shorter fight, 20 rounds at a time, a magazine emptied in a heartbeat, and a reload that left him silent while the enemy was not. Neither man could do the other's job. The Army wanted one weapon and one load that could do both, and it wanted the load to be one a single soldier could carry forward at a walk. That was the specification. Underneath the specification, the human requirement the 18-pound figure was meant to capture. The answer would not be invented from a blank sheet. It would be assembled, part by part, from two captured guns already sitting on an American workbench. Chapter 2. Two German guns in an American workshop. The M60 was not born in a flash of genius. It was two enemy weapons taken apart and rebuilt on an American bench. That fact matters, because the popular telling likes a single inventor. It likes one man with a drawing and a breakthrough. The record of the M60 does not offer him. What it offers instead is a program run through the United States Army Ordnance Corps, worked at government arsenals such as Springfield Armory and Watertown Arsenal, and carried into hardware by an industrial partner, Bridge, Tool, and Die Works. The gun had many hands and no single father. That claim, that one man invented the M60, requires restraint. The evidence points to an institution, not a genius. The institution began with what it had captured. Two German weapons sat at the center of the work, and each contributed a different half of the new gun. The first was the FG-42, the rifle built for German paratroopers. Its origin was itself a lesson learned the hard way. After the airborne assault on Crete in 1941, German planners wanted a single weapon, light enough to jump with and powerful enough to serve as a squad's automatic once on the ground. The FG-42 was the answer, and inside it sat a gas-operated action with a rotating bolt that the American designers found worth keeping. The second weapon was the Meters G42, the general-purpose gun whose rate of fire had haunted Allied infantry. The Americans did not want its roller-delayed speed. They wanted its feed. The Meters G42 pulled its belt through the gun with a camming mechanism worked by the moving bolt, housed under a hinged top cover that flipped open for loading. That feed system was elegant and fast and reliable, and it became the top half of the American design. So the recipe was set. Take the operating system of the FG-42, the gas piston and the rotating bolt, and put it under the feed mechanism and top cover of the Meters G-42. The first attempt to do exactly that was the T-44, and work on it reached back to 1946. The T-44 was a hybrid in the most literal sense, an FG-42 action married to a Meters G-42 top cover chambered in the wartime 30-06 cartridge. It fired. It also revealed the first trade-off of many. Built light. With stamped steel to save weight, the T-44 proved too light for sustained fire. A gun that would serve as a company's base of fire needed mass to stay steady and to soak up heat. The requirement wanted light and steady at once, and the two pulled against each other from the first prototype. That tension explains why the work took years rather than months. Each fix exposed a new problem. Adding mass for steadiness added weight for the carrier. Stamping parts to cut weight raised questions about durability. Borrowing proven German mechanisms saved the program from inventing an action from nothing, and it also locked in design choices that would later sit badly in a soldier's hands. The gun inherited its parents' strengths. It also inherited the seams where two different weapons had been forced together. There was a second reason the borrowing made sense. Beyond speed. Proven mechanisms carried proven behavior. The FG-42's rotating bolt had already shown it could lock and unlock reliably under a rifle's pressures. The Meters G-42's feed had already shown it could drag a belt through mud and keep dragging. Starting from those two known quantities meant the American designers spent their effort on integration rather than on discovery. That was a sound engineering choice. It was also the choice that would later put a bipod, a gas cylinder, and a front sight all on a single removable barrel, because the pieces came from designs that had solved those problems separately. The cartridge changed underneath the whole effort while the mechanical work went on. The wartime 30-06 was giving way to a new standard round, the 7.62 by 51 mm, adopted across the young NATO alliance to let Allied armies share ammunition. A gun meant to serve for decades had to speak that new language. The move from 30-06 to 7.62 NATO forced another round of redesign, because a shorter, different cartridge changes the timing and the geometry of everything that feeds, chambers, and extracts it. That combination of tasks, integrate two mechanisms, add mass without adding too much weight, and convert to a new cartridge, is why the design race stretched across most of a decade. It was not indecision. It was the slow work of making three separate demands agree inside one receiver. By the time the effort matured, the shape of the future gun was visible. It had the vertical grip of its paratrooper ancestor. It had the belt feed of its general-purpose ancestor. It had a barrel meant to be swapped when it grew hot. And it was built to be stamped and welded from sheet steel rather than milled from solid billets, because the Army wanted a gun that could be mass-produced in a hurry if a war demanded it. The borrowing had saved years. It had also written the gun's future arguments into its ancestry. A weapon, assembled from two others, would carry the habits of both, the good and the awkward, into every unit that ever fielded it. The paratrooper rifle at the center of the work had a history worth pausing on, because it explained the qualities the Americans wanted. The FG-42 had been built for men who jumped into battle carrying everything on their bodies, and it had to be a rifle and a light automatic at once, controllable and compact. Its gas-operated action and rotating bolt were the product of that demand for a light weapon that could still fire a full-power cartridge. Those were exactly the traits an American general-purpose gun needed, and so that action, rather than the roller-delayed system of the Meters G-42, became the heart of the new weapon. The design also drew, more distantly, on older air-cooled light machine guns, whose barrel and gas arrangements had helped establish how such weapons managed heat. The result was a gun with several bloodlines, a paratrooper's action, a general-purpose gun's feed, and the accumulated practice of a generation of automatic weapons. The early hybrid, the T-44, made all of this literal. It was stamped from steel to keep it light. It married an FG-42 action to a Meters G-42 top cover, and it fired the old 30-06 cartridge. It also failed in an instructive way, proving too light to fire steadily for long. That failure was not wasted. It told the designers precisely which way the next version had to move, toward more mass, more strength, and the new NATO cartridge that was about to become the standard. A promising hybrid, though, was still only a hybrid. It had to survive the trials that turned prototypes into standard issue, and it had to answer for a weight limit it was about to break. Chapter 3. 18 pounds on paper, 23 in the hand. The requirement asked for 18 pounds. The gun that won the competition weighed 23. That gap of 5 pounds sounds small on a page. It was not small on a march. 5 pounds is the difference felt in the shoulders at the end of a day. The weight that turns a manageable load into a resented one. The number that had been a promise to the carrier became, quietly, the first debt the gun owed him. And it was paid before the weapon ever reached a soldier's hands. The debt was earned honestly, in the sense that it bought something. The trials that shaped the final gun ran through a series of prototypes, and each one taught the designers what the requirement could and could not have at the same time. The early hybrid, the T-44, had been judged too light to hold steady under sustained fire. The lesson was clear. A gun that fed from a belt and served as a base of fire needed enough mass to stay planted while it worked, so mass came back. Steadiness was bought with weight, and the carrier signed the note. The line of prototypes tells the story in designations. The T-44 had proven the concept and its limits. A successor, the T-52, resembled the eventual gun far more closely and moved the design onto the 7.62 NATO cartridge. But it still lacked the quick-change barrel the requirement demanded, and a general-purpose gun without a fast barrel change is a gun that overheats and stops. The design pressed on to the T-161, refined specifically to be built in quantity, and then to the T-161E3, the version that satisfied the trials and became standard. The Army type classified it as the M60. The exact year of that adoption is one of the places where the sources do not agree. Some record the type classification in 1957. Others cite 1959. Others emphasize that issue to units, and the first real service came around 1960, with widespread combat use only arriving later. That spread of dates is not a contradiction to be hidden. It is the normal blur between a design being accepted, a contract being let, and a weapon actually reaching a soldier's hands. Any single clean year for the M60's birth requires restraint. The honest statement is that the gun was accepted in the late 1950s and reached troops at the turn of the decade. What is not blurry is the weight. The requirement had named 18 pounds. The M60 came in at roughly 23. The gun that was meant to lighten the squad's load arrived heavier than promised, and it arrived that way for reasons the trials had made unavoidable. It needed the mass to fire steadily. It needed a barrel heavy enough to endure. It needed a receiver strong enough to contain a full-power cartridge fired on automatic. Each of those needs was real. Together, they broke the number that had justified the whole program. That is the trade-off at the heart of the adoption. The advantage was a genuine, general-purpose gun, belt-fed, quick-change-barreled, chambered for the new NATO round, capable of both the bipod and the tripod roll. The cost was 5 pounds over the promise, carried by the man who already carried the most. The one who paid was the gunner, and behind him the assistant gunner, and behind them the rifleman who split the belts. It is worth being fair to the gun here, because the weight bought real capability. The M60 could do what the Browning automatic rifle could not. It fed from a long belt rather than a 20-round box, so it could sustain fire instead of stuttering to a reload every few seconds. It could do what the heavy Brownings could not. It could be picked up off its bipod and carried forward with the assault rather than left behind on a tripod. On paper, the gun closed both halves of the old gap in a single weapon. That was exactly what the requirement had asked for, and the gun delivered it. The rate of fire showed the same balance of judgment. Where the German Meter's G42 had torn through roughly 1,200 rounds a minute, the M60 was set much lower, in the range of 550 to 650 rounds per minute, with the lower figure the one most often cited. That slower cadence was a deliberate correction of the German excess. It let a gunner fire in controlled bursts, it saved barrels from the worst of the heat, and it let a crew feed the gun with ammunition it could realistically carry. The sedate rate was not a weakness. It was the lesson of the Meter's G42 applied. The numbers around the gun filled in the rest of its character. The barrel ran 22 inches. The cartridge left the muzzle at roughly 2,800 feet per second. On its bipod, the gun could reach point targets out to about 1,100 meters, and its rounds could travel far beyond that, to a maximum near 3,700 meters when fired for area effect. It fed from a disintegrating belt built on metal meters, 13 links, so the belt fell apart into loose links as it was consumed rather than staying as a long strip to manage. Each of those numbers was a small promise about what the gun could do, and most of them the gun kept. The weight was the promise it broke, and the breaking set the tone. From the first day of issue, the M60 was a gun that asked more of its carrier than the paper had said it would. Everything the men later did to it, every field modification and every complaint, started from that fact. They had been promised a lighter load and handed a heavier one, and they made the best of it because the firepower on the other side of the ledger was real. The rest of the gun's numbers filled out the portrait of a weapon built for a crew rather than a lone man. Its sights were iron. A protected front post carried on the barrel and an adjustable rear leaf on the receiver graduated for the ranges a machine gun was expected to reach. For sustained fire, it locked onto a tripod, the Meter's 122, which added its own weight to the system but turned the gun into a stable, long-range base of fire that a bipod could never match. A belt of 100 linked rounds was itself a load of several pounds, and a gun in action consumed such belts quickly, which is why the ammunition was spread across the whole squad rather than piled on one man. Each of those figures pointed back to the same truth. The M60 was a system, not a rifle, and its weight was the weight of a system: gun, spare barrel, bipod, tripod, and belts, distributed across several soldiers. The 18-pound promise had described only the gun itself, and even that promise had broken to 23. The real burden, counted honestly across the crew, was far larger. That was the true cost of belt-fed firepower on the move, and it was a cost the paper requirement had never fully admitted. The men would meet the full bill in the field, added pound by pound to loads they already carried, in a climate that made every pound heavier than it was. With the design frozen and the gun accepted, the argument moved from what it weighed to what it did. To understand every strength and every flaw that followed, the gun has to be watched doing the one thing it was built for. It has to be watched firing a single round, from the pull of the trigger to the fall of the empty link. Chapter 4. One pull of the trigger, start to finish. The M60 fired from an open bolt, and almost everything it did well and badly began with that single choice. One firing cycle explains the entire gun. Firing from an open bolt means the weapon rests, between bursts, with its bolt held all the way to the rear. Nothing sits in the chamber. When the gunner presses the trigger, the sear releases the bolt, and only then does a round begin its journey into the gun. That arrangement has a purpose. A machine gun runs hot, and a cartridge left sitting in a hot chamber can ignite on its own from the heat alone. By keeping the chamber empty between bursts, the open bolt design lets air move through the barrel and reduces the risk of a round firing before the gunner wants it to. The choice was made for cooling, and cooling was the whole problem a machine gun had to manage. So the cycle starts with a release rather than a squeeze. The sear drops. The compressed drive spring, which has been holding the bolt group at the rear, shoves the whole assembly forward. As the bolt runs ahead, its face meets the first cartridge waiting on the belt, strips it from its M13 link, and drives it toward the chamber. The round rises along the feed path, its base caught by the bolt, its nose guided into the chamber mouth. The bolt does not simply slam shut. As it reaches the end of its travel, an operating rod and a cam turn the bolt so that its two locking lugs rotate behind matching shoulders in the barrel extension. That rotation is the inheritance from the paratrooper rifle, the FG-42, and it is what lets the gun contain the full pressure of a 7.62 NATO cartridge. The bolt is now locked. The chamber is sealed. Only at the very end of that motion does a firing pin reach the primer, and the cartridge fires. What happens next is the part that gives the gun its name as a machine. The bullet races up the 22-inch barrel. Before it reaches the muzzle, it passes a small port drilled into the underside of the barrel, and a jet of high-pressure gas bleeds off through that port into the gas system below. This is where the M60 shows its cleverest idea. Its gas system is built around an expansion and cutoff principle, a design associated with the engineer Carl White, which makes the system largely self-regulating. A measured volume of gas drives the piston, and once that volume has done its work, excess pressure is vented away through a bleed hole at the front of the gas cylinder rather than being forced through the mechanism. The gun takes what it needs and spits out the rest. That vented gas has already pushed the piston and the operating rod to the rear. The moving rod first rotates the bolt back the other way, unlocking the two lugs from their shoulders, and then drags the whole bolt group rearward against the drive spring. As the bolt travels back, an extractor claw grips the rim of the spent cartridge and pulls it from the chamber. An ejector flips the empty case out through the bottom of the gun, where it falls away with the loose link that had held it. The belt, meanwhile, has been pulled one step further across the feed tray by the camming mechanism under the top cover, the inheritance from the Meter's G42, so that a fresh round now waits in the path. At the rear of its travel, the bolt group compresses the drive spring fully. If the gunner still holds the trigger, the sear stays down, the spring drives the bolt forward again, and the entire sequence repeats: strip, chamber, lock, fire, unlock, extract, eject, feed, 550 to 650 times a minute. If the gunner has released the trigger, the sear rises and catches the bolt at the rear, and the gun returns to rest with an empty chamber, ready and cool. That is the whole machine in one breath. Every advantage the M60 offered lived somewhere in that cycle. The open bolt fought cook-off. The rotating bolt contained a powerful cartridge. The self-regulating gas system adjusted itself to conditions. The disintegrating belt let the gun feed a long stream of fire without a box to empty. The popular imagination, though, remembers the machine gun as a weapon that cooks off, that keeps firing on its own once it grows hot. For the M60, that image needs correcting. An open-bolt gun, sitting with an empty chamber between bursts, is precisely the design that resists cook-off, because there is no round in the hot chamber to ignite. When a M60 ran away, firing until its belt was empty with the gunner's finger off the trigger, the usual cause was not heat in the chamber. It was a worn sear that could no longer catch and hold the bolt at the rear. The gun that would not stop was almost always a gun with a mechanical fault in its trigger group, not a gun cooking its ammunition. That distinction matters, because it moves the blame from the laws of physics to the details of manufacture and maintenance. And those details were where the trouble lived. The same self-regulating gas system that was the gun's cleverest feature had a habit that undid it. Its components could work loose under the pounding of high round counts. Worse, The gas parts could be reassembled in the wrong order or the wrong orientation after cleaning, and a gun put back together incorrectly might refuse to cycle at all or cycle in a way it should not. The advantage was a gas system that tuned itself. The cost was a gas system that demanded to be understood, and that punished the man who understood it imperfectly. The one who paid was the gunner in the field, cleaning his weapon by feel in bad light, trusting that the pieces went back the way they had come apart. Two details of that cycle deserve a closer look, because both became sources of trouble in the field. The first is the matter of headspace and timing, the precise fit between the bolt and the barrel that lets the gun lock and fire safely. On the M60, the barrel and bolt worked as a matched relationship, and because the barrel was a removable, swappable part, that relationship had to hold across barrel changes. When it drifted, through wear or a poorly fitted spare, the gun's reliability drifted with it. The second detail is the gas system's assembly. The self-regulating design depended on a small stack of components, a piston and a plug, and the cylinder that held them, going back together in a specific order and orientation after cleaning. Reassembled correctly, the system tuned itself. Reassembled backward, with the gas plug reversed, the gun might not cycle at all, or might behave in ways it should not. A gunner cleaning his weapon in poor light, by feel, after a long day, had to get a fiddly reassembly exactly right or pay for it the next time he pressed the trigger. The cleverness that made the gas system self-regulating also made it unforgiving, and it placed the burden of that cleverness on a tired man's fingers. The open bolt design carried its own smaller cost as well. A slight lag between the trigger pull and the first shot as the whole bolt group ran forward, and a first round less precisely placed than a closed bolt weapons. For a machine gun firing bursts, that was an acceptable price. It was still a price. A clever cycle, understood on a bench, was one thing. Building that cycle into hundreds of thousands of guns, cheaply and quickly, was another problem entirely, and it fell to a very different set of hands. Chapter 5. The guns that came from sheet metal. Winning the trial was the easy part. Building 250,000 of the winning gun was the second war, the one fought on factory floors. A machine gun is only as good as the number a nation can field, and the M60 had been designed from the start with that arithmetic in mind. It was meant to be stamped and welded from sheet steel rather than machined from solid blocks. Milling a receiver from billet steel produces a strong part and consumes hours of skilled labor and expensive tooling for each one. Stamping a receiver from sheet metal produces a part in a fraction of the time, on presses that can be run by a broader workforce, at a cost that lets a country arm quickly. The choice to stamp the M60 was a choice about how fast America could make machine guns if it suddenly needed a great many. The industrial lineage ran through several hands. The early development hardware came through Bridge Tool and Die Works, the partner that had helped turn captured German mechanisms into an American prototype. Inland Manufacturing, a division of General Motors that had built vast quantities of small arms during the Second World War, was part of the industrial base the program drew on. As the gun matured into a standard weapon, series production settled with Sacco Defense in Maine, a firm tied to the Merrimont Corporation, and Merrimont itself. In later decades, the name U.S. Ordnance joined the list of makers. These were not romantic names. They were tool and die shops and defense contractors, the ordinary machinery of a country that turns designs into hardware by the thousand. The scale they reached was large. By the 1980s, more than 250,000 M60s had been built, and through the peak years of the Vietnam War, the plants were turning out tens of thousands annually. That output is the hidden half of the gun story. The famous images are of the gun in the jungle or on the screen. The unglamorous truth is that the gun existed in those places only because presses in New England stamped its parts fast enough to keep divisions supplied. Mass production carried its own logic, and that logic depended on one demanding idea: interchangeability. A gun assembled from stamped parts across multiple contractors only works if a bolt from one plant fits a receiver from another, if a feed tray built on a Tuesday matches a top cover built a month later. That arrangement depended on tolerances held tightly across many hands. When it held, an armorer could rebuild a damaged gun from a bin of spare parts. When it slipped, the same interchangeability that was meant to speed repair could pass small inconsistencies from part to part. The stamped construction that made the gun affordable is also where the durability arguments began. Critics pointed to the sheet metal receiver and the stamped feed tray and saw corners cut. There was truth on both sides of that argument. The stampings did make the gun buildable in the numbers a war required, and no milled receiver gun could have been fielded as fast or as cheaply. At the same time, a sheet metal receiver has limits, a block of steel does not, and over a long service life, those limits showed. Receivers could stretch under tens of thousands of rounds, and after roughly 100,000 rounds, a receiver might begin to develop cracks. The gun was built to be made in quantity, and quantity and longevity are not the same virtue. That was the ledger of the factory. The advantage was speed and cost, a gun that a nation could produce by the tens of thousands in a hurry. The cost was a structure with a finite life, a receiver that would eventually stretch or crack under sustained use. The ones who paid were the armorers who condemned worn receivers and the gunners who inherited a weapon whose frame had a mileage limit written into its very method of manufacture. There is a temptation to read sheet metal as cheap junk, and that reading needs restraint. Stamped construction was not a sign of a bad gun. It was a deliberate industrial strategy, the same strategy that had let Germany flood its own front with Meters G42s. The Soviets would prove the same point with stamped rifles that armed half the world. A stamped weapon can be a superb weapon. The M60's stampings were a rational answer to the question of how to arm an army quickly, and the answer was mostly correct. The problems that dogged the gun were less about the fact of stamping than about specific design decisions frozen into every stamped copy. Because that was the quiet danger of mass production. A flaw milled into one prototype is a flaw in one gun. A flaw stamped into a production line is a flaw in every gun that line produces, repeated 250,000 times. Whatever the designers got right was multiplied across the whole force. Whatever they got wrong was multiplied exactly as faithfully. The presses did not judge. They copied. The industrial base behind the gun reached back into the arsenals and firms that had armed the country through the World War. Inland's parent, General Motors, had turned automobile plants into weapons plants once already, and that institutional memory, how to make a complex small arm in enormous numbers, was part of what the M60 program drew on. The work was ordinary industrial labor, presses and jigs and inspection gauges, carried out by a workforce that did not need to be gunsmiths because the design had been engineered so they would not have to be. That was the promise of interchangeability, and it was also its exposure. When tolerances held across every contractor and every lot, an armorer could reach into a bin and rebuild a gun from mixed parts, and a damaged weapon could be returned to service in minutes. When tolerances slipped, the same mixing that was meant to speed repair could put a slightly loose part against a slightly tight one, and small inconsistencies could stack into a gun that fed or fired a little worse than its neighbor. Quality control across many plants and many years was therefore not a paperwork exercise. It was the difference between a force of guns that all behaved alike and a force in which every weapon had its own temperament. The heavy use of stampings raised the stakes further, because a stamping die that drifted out of specification could turn out flawed parts by the thousand before anyone noticed. Errors caught early cost a single component. Errors caught late could reach the field in crates. And the drawings they copied contained several decisions that would meet the men who carried the gun not on a proving ground, but in a paddy, in the dark, with a hot barrel and a jammed belt. Those decisions were not wear. They were choices, faithfully reproduced, waiting in every crate. Chapter 6. The flaws built in at the factory. Some of the M60's worst problems were not the result of hard use. They were decisions, made once on a drawing and then repeated 250,000 times. The most consequential of them sat on the barrel. A general-purpose machine gun lives or dies by its ability to change a hot barrel quickly, and the M60 could change its barrel. The problem was what came off with it. On the M60, the bipod was mounted to the barrel. So was the gas cylinder. So was the front sight. When a gunner removed a hot barrel, he removed all three of those pieces attached to it, and the spare barrel he installed brought its own bipod, its own gas cylinder, and its own front sight with it. Every consequence of that single decision was a burden. Because the bipod rode on the barrel, every spare barrel was a spare bipod too, so each replacement barrel weighed more and packed more awkwardly than a bare tube would have. Because the front sight rode on the barrel, changing barrels could shift the gun zero, and a gunner who swapped barrels might find his point of aim had moved. Because the gas system was tied to the barrel assembly, the act of changing barrels touched the very mechanism most sensitive to being reassembled correctly. One design choice, the decision to hang those parts on the barrel, generated 3 separate penalties, and all of them landed on the crew. The barrel carried one more insult, and it was the absence of something rather than the presence of it. The M60's barrel had no carrying handle of its own. The German Meters G42, the very gun whose feed the M60 had borrowed, wore a handle that let a crewman grab a scorching barrel and swap it in seconds. The M60's barrel offered no such grip. The Army's answer was an asbestos mitt, an insulated glove issued so the gunner could seize the red-hot steel and pull it free. The idea worked on a range. In a firefight, the reality of a man setting down his weapon to find and pull on an oven mitt while the barrel glowed did not work out well, and the mitt had a way of being lost exactly when it was needed. The tool that solved the problem on paper created a new problem in the mud. The gas system carried a flaw of its own, separate from its sensitivity to reassembly. The nut, or plug, that held the gas cylinder together had a tendency to loosen and back itself out under the vibration of high round counts. A gunner could fire a long engagement and find the gas system working its way apart. The field remedy became famous for its crudeness. Gunners wired the gas cylinder together, with safety wire when they had it, and with a length of coat hanger wire when they did not. A gun that had emerged from a modern stamping line was kept whole by the same wire used to hang a jacket. The advantage of a self-regulating gas system was undercut by a fastener that would not stay fastened. The trigger group held the runaway problem. The sear that caught the bolt at the rear could wear, and a worn sear might fail to hold, so the gun would keep firing after the gunner released the trigger, emptying its belt on its own. The fire control group was retained by pins held under a flat spring, and that retaining arrangement could shift, in the worst case letting the group loosen. These were not exotic failures. They were the predictable aging of small, highly stressed parts, and they turned a controllable weapon into an unpredictable one when they went wrong. Even the barrel latch had its story. The early mechanism that locked the barrel in place could be caught and released by brush and foliage as a gunner moved through dense growth, so a man pushing through jungle could find his barrel had unlatched on its own. That specific flaw was addressed with a field fix, a change to a push-button release introduced around 1966. It is one of the clearest examples of the pattern that defined the gun's whole life, a problem discovered in use, then patched after the fact rather than prevented in design. The trade-off ledger of this chapter is the ledger of the gun itself. The advantage of putting the bipod, gas system, and sight on the barrel was a self-contained barrel assembly, a unit that carried everything it needed. The cost was weight, a shifting zero, and a delicate mechanism disturbed at every change. The ones who paid were the gunner who humped the heavier spares and re-zeroed after every swap, and the assistant gunner who carried those spare barrels with their attached bipods across his own back. It would be unfair to call the M60 a bad gun on the strength of these flaws alone, and fairness is the point. The gun fired a powerful cartridge accurately. It fed reliably when clean and correctly assembled. Its rate of fire was controllable, and many of the men who carried it trusted its firepower absolutely. The flaws were real, and they coexisted with genuine strengths. That is the honest shape of the weapon. An effective gun burdened by a handful of decisions that its own users spent years working around. There were smaller design frustrations that compounded the large ones. On the original gun, the feed tray cover could not be closed while the bolt was forward, so a gunner had to remember the correct state of the weapon before loading, one more step to get right under pressure. The fire control group was held in place by pins retained under a flat spring, and that spring and its plate could shift, in the worst cases allowing the trigger assembly to work loose. None of these was catastrophic on its own. Together, they added up to a weapon that demanded attention to detail at every turn, a gun that punished the ordinary lapses of tired men. The barrel decisions carried a second-order cost beyond the weight and the shifting zero. Because a spare barrel was a heavy, awkward assembly with its own bipod and gas parts, crews under load were tempted to carry fewer spares than doctrine called for, or none at all. A gun without a spare barrel could not change a hot barrel, and a barrel fired too long without a change overheats, wears, and loses accuracy, and in the extreme can be ruined. So the design that made spares heavy quietly discouraged carrying them, and the shortage of spares then undercut the very sustained fire capability the heavy barrel had been meant to provide. One awkward decision on a drawing rippled outward into how the gun was supplied and used, and every ripple cost the crew something. Those decisions had been made on drawing boards and frozen into steel. The men who would live with them had not been consulted, and they were about to meet the gun where consultation ends. They would meet it in the rice paddies, where the promise of firepower and the price of design met in the same hands. The Army had built the gun to close a gap in the arsenal. The jungle would decide what the gun had actually become. Chapter 7. The pig arrives in the rice paddies. In Vietnam, the M60 earned a name within days of arriving, and the men who gave it meant two things by the same word. They called it the pig. The name was first about the body of the gun. At roughly 23 pounds empty, the M60 was a heavy thing to carry through heat and water and mud, and it grew heavier the moment a belt was loaded. A soldier who humped everything he owned through a tropical forest felt the gun's weight in a way no specification sheet could capture. The pig was the load that never got lighter, the animal that had to be dragged along wherever the squad went. The name was also about appetite. The M60 fired a full-power 7.62 cartridge on automatic, and gunners quickly learned that the gun could do to cover and to buildings what rifles could not. A burst could tear through the flimsy walls of a structure. The gun ate ammunition to do it, and it ate it fast, so the same word that described the weight also described the hunger. The pig was heavy, and the pig was always feeding, and both readings were true at once. Feeding it was a job for more than one man. The gun ran with a gunner and an assistant gunner, and the whole squad became part of its supply. The gunner carried the weapon and a starting belt, often draped across his chest in the image that would later define the gun. The assistant gunner carried the spare barrel, with its attached bipod and additional belts of ammunition. And because a machine gun's appetite outran what two men could carry, the riflemen of the squad each hauled a belt or two of linked 7.62 as well, handing them forward when the gun's own supply ran low. The M60 was not one man's weapon. It was the squad's weapon, and the squad's back paid for it collectively. That distributed load was the price of the firepower, and the firepower was worth it. A single M60 gave a squad a base of fire it had never possessed in one weapon. It could pin an enemy in place while the riflemen maneuvered. It could break up an assault. It could reach out to 1,100 meters and beyond. The gap that the Browning automatic rifle had left, the suppression that stopped every few seconds to reload, the M60 filled with a belt that could run long. For all the complaints that would follow, the gun did the one thing it had been designed to do. It kept belt-fed fire moving with the squad. Keeping that fire useful required discipline, and doctrine supplied it. Gunners were trained to fire in short bursts, on the order of 5 to 8 rounds, rather than holding the trigger down. The reasons were practical. Short bursts conserved ammunition that had to be carried on human backs. Short bursts spared the barrel from the heat that would otherwise force a change. And short bursts kept the gun's fire accurate, because a long burst climbs and wanders as recoil builds. A well-run M60 in a firefight fired in a rhythm, brief bursts with pauses between them, so that a gun with a cyclic rate near 550 rounds a minute actually put out something closer to 100 rounds in a minute of real fighting. The gap between the cyclic rate and the practical rate was the gunner's judgment, exercised trigger pull by trigger pull. The glamour of the belt-draped gunner deserves a moment of restraint, because the image and the reality diverged. Photographs and films fixed the picture of a man walking with a belt of ammunition slung across his chest, and it was a real practice, a way to keep a ready belt at hand. It was also hard on the ammunition. A belt worn across the body collected dirt and sweat and could be knocked out of shape, and dirty or deformed rounds and links were among the things most likely to jam the gun. The dramatic image and the careful maintenance the gun demanded sat uneasily together. What looked like swagger was, for a gunner who wanted his weapon to work, a compromise to be managed rather than a pose to be struck. The environment fought the gun as hard as any enemy. The heat and humidity of the jungle worked at the lubricant and the metal. The mud and the paddy water found their way into the action. Sand and grit, picked up anywhere the gun was set down, could foul the mechanism. A machine gun in Southeast Asia needed constant attention simply to keep functioning, and a gun neglected in those conditions would eventually remind its crew of the fact. The M60 was not unique in suffering from the climate. It was, however, a gun with a sensitive gas system and tight-fitting parts, and the climate had many ways in. So the gun arrived carrying both halves of its nature into the same rice paddies. It was the weapon the squad could not do without, the source of a firepower that saved lives in the worst moments of a fight. It was also the burden the squad resented, the heavy, hungry animal that 4 men fed and 1 man cleaned by feel in the dark. The love and the hatred were not contradictions. They were 2 accurate descriptions of the same steel. The gun's supply chain, spread across the squad, shaped how a unit moved and fought. Because everyone carried ammunition for the pig, the gun's needs became the squad's needs, and a firefight that fed the gun heavily left the whole squad lighter and more vulnerable afterward. That interdependence was the price of concentrating so much firepower in one weapon. It made the gunner the center of the squad's fight, and made his ammunition everyone's responsibility. On the ground, the gun served from its bipod in the assault, and from its meters 122 tripod in the defense, and the tripod version showed the weapon at its best, stable, accurate, and able to reach far out across a perimeter at night. The climate worked against all of it. Heat thinned the lubricant. Humidity and paddy water crept into the action. Fine grit picked up on any patch of dry ground could foul the mechanism. A gun set down in the wrong place for a moment could take in enough dirt to matter. The men learned to keep the weapon covered, cleaned, and lubricated with a discipline the conditions constantly undid, because a machine gun that failed at the wrong moment failed everyone who depended on its fire. The firepower was the squad's greatest asset, and keeping it available was a full-time job laid on top of every other job a soldier already had. Loving the firepower was easy. Keeping the gun alive to deliver it was the harder fight, and it was a fight the men waged with wire, with ration cans, and with an oven mitt. Chapter 8. Coat hangers, sea ration cans, and an oven mitt. The M60 ran best on improvisation. Its users finished, in the field, a design the factory had left unfinished on the bench. The most common fix addressed a feeding problem. As the gun pulled its belt across the feed tray, the loose end of the belt could bind or hang up, and a belt that snagged could jam the works at the worst possible instant. Gunners found their own answer. They wired an empty sea ration can to the left side of the gun, just below the feedway, so that the belt fed up out of the can in a smooth curl instead of dragging and binding. The ration can, emptied of its meal, became an ammunition guide. It was not in any manual. It spread from gunner to gunner because it worked, and it turned a small daily frustration into a solved problem with a piece of trash. The gas system got the coat hanger. The plug or nut that held the gas cylinder together backed itself out under sustained firing, and a gun could shed part of its own gas system in the middle of an engagement. so gunners wired it shut. Safety wire held the gas cylinder together when safety wire was available, and a length of coat hanger wire held it together when it was not. A modern machine gun, stamped and welded on an American production line, was kept whole in combat by the same wire used to hang clothing in a closet. The improvisation worked, and the fact that it was necessary told the whole story of the gap between the drawing and the ditch. The barrel change was the fix that could not be fully fixed. When a barrel grew too hot from sustained fire, it had to be swapped, and the M60's barrel had no handle to grab. The issued solution was the asbestos mitt, an insulated glove for seizing the glowing steel. In the calm of a training range, the mitt did its job. In a firefight, it failed the test of reality. A gunner under fire had to stop firing, locate the mitt, pull it on, release the hot barrel, remove it, seat the spare with its attached bipod, and get back into action, all while the fight went on around him. The mitt was often lost, and a gunner without it faced a hot barrel and bare hands. What the design had treated as a solved problem, the combat reality reopened every time a barrel needed changing. Then there was the runaway gun, and it demands the channel's habit of listing every cause before the popular one. When an M60 kept firing after the trigger was released, emptying its belt on its own, the temptation is to blame heat, to say the gun cooked off. The record points elsewhere. The most common cause of a runaway M60 was a worn sear that could no longer catch and hold the bolt. But the honest accounting does not stop there. A stoppage or a malfunction in these guns could arise from a worn sear, from a gas system reassembled incorrectly, from a gas plug installed the wrong way, from dirt and grit in the action, from a damaged or dirty belt, from deformed links, from bad or corroded ammunition, or from lubricant that had degraded in the heat. The gun had many ways to fail, and only after all of them are named is it fair to reach for any single explanation. The cause might lie in the sear, the gas parts, the belt, the links, the ammunition, the dirt, or the lubricant, and often it lay in more than one at once. That fairness cuts against a popular verdict. The M60 is sometimes remembered as a gun that jammed constantly, a weapon its users could not trust. That claim requires restraint. Many gunners trusted the M60 completely and would not have traded its firepower for anything they could carry. The gun's failures were real, but they were largely the failures of a design that demanded correct assembly and constant maintenance, operated in the hardest conditions on Earth by tired men. A well-maintained M60, correctly assembled, fed clean ammunition, was a reliable and formidable weapon. The reputation for constant jamming came partly from the guns that were not maintained, not clean, or not correctly put back together, and partly from the sheer number of the weapons in service, which meant even a modest failure rate produced many failures to remember. The improvisations, though they worked, carried their own second-order costs, and honesty requires naming them. The ration can added a step to loading and one more thing to lose. The wire around the gas system held it together and also signaled that the system could not be trusted to hold itself, which meant a gunner had to check it. The MIT, when present, added an item to manage under fire. Each fix solved a problem and created a smaller one, a new task, a new dependency, a new thing to remember in a moment when memory was already overloaded. The men absorbed those costs because the alternative, a gun that fed poorly, shed its gas system, or could not change a barrel, was worse. What emerges from all this is a portrait of a partnership between the gun and its crew that was closer than it should have had to be. A well-designed weapon asks little of its user beyond aiming and firing and cleaning. The M60 asked more. It asked to be wired, canned, mitted, checked, and understood in intimate detail, and it rewarded the men who did all of that with real firepower. The relationship worked. It should not have required a coat hanger. Maintenance, more than any single modification, was what separated a reliable M60 from an unreliable one. The gun rewarded a crew that stripped it, cleaned it, checked its gas system, inspected its belts and links, and replaced worn parts before they failed. It punished neglect quickly. Much of the weapon's mixed reputation traces to that sensitivity. In units where the gun was maintained with discipline, it worked, and its gunners defended it. In circumstances where maintenance slipped, under exhaustion, under constant movement, under the sheer friction of a long campaign, the same gun faltered, and its failures became the stories that outlived it. There is a fairness owed here that popular memory rarely extends. Every automatic weapon in that war demanded maintenance, and every one could be made to fail by the climate and by neglect. The M60's particular sins, the loose gas plug, the missing barrel handle, the fiddly reassembly, made it less forgiving than it should have been, but they did not make it uniquely worthless. A gunner who knew his weapon intimately could keep it running through conditions that would stop a neglected gun cold. The wire and the ration can and the mitt were the visible signs of that intimacy, the marks of men who had learned the gun's every weakness and built the habits to work around each one. The improvisation was not a verdict of failure. It was a form of mastery, forced on the men by a design that asked too much. Some men grew tired of adapting themselves to the gun and began adapting the gun to themselves instead. They stopped waiting for the army to fix it, and they took a hacksaw to it. Chapter 9. The Men Who Cut It Down. The gun escaped its own manual. In the hands of raiders and helicopter crews, the M60 became something its designers had never drawn. The escape happened because the gun's assigned role and the actual fights men found themselves in did not match. The M60 had been designed as a squad and company weapon, fired from a bipod or a tripod, delivering sustained fire at range. But not every fight was a base of fire fight at 1,100 meters. Some fights were close and fast, in dense growth or on narrow waterways, where a full-length 23-pound machine gun was an awkward companion. And some fights happened from the open door of a moving helicopter, a position the ground roll gun had not been built for. In each of those settings, the men took the gun and reshaped it. The most dramatic reshaping came from special operations and reconnaissance units, who cut the gun down. They shortened the barrel and trimmed the weapon to make it handier for close work, producing a compact machine gun that could be carried and swung in tight terrain where the full-length gun could not. A shortened, chopped M60 gave a small team the firepower of a belt-fed gun in a package closer to the size of a rifle. These cut-down guns were field-modified weapons, adapted to a mission the standard configuration did not serve, and they show how far the men were willing to go to make the gun fit the fight. It should be said with restraint that the exact nicknames attached to these cut-down guns vary in the retelling, and specific labels are not always documented as cleanly as the modifications themselves. What is well attested is the practice. Elite units did shorten and lighten the M60 for close quarters and jungle work, valuing its firepower enough to modify it rather than abandon it. The precise slang deserves a lighter touch than the fact of the modification, which is solid. The helicopter crews performed their own adaptation. A door gunner needed a weapon he could swing across a wide arc from a moving aircraft, fire in long engagements, and manage in a cramped, wind-blown space. The standard M60 was pressed into that job, and the crews modified it to suit. They hung the gun from a bungee cord clipped to the airframe, so that the weight was borne by the aircraft and the gunner could aim and traverse without holding the full mass. They chopped barrels to make the gun handier in the door. And they applied the same field wisdom the ground gunners used, including the wired-on ration can to keep the belt feeding smoothly as the aircraft maneuvered. The Army also fielded a purpose-built door gun version, the M60D, fitted with spade grips and mounted on a pintle for exactly this role, an acknowledgement that the improvised helicopter gun had become a permanent fixture. Each of these adaptations was a trade-off, and each ledger balanced the same way. Cutting a barrel down bought handiness and made the gun easier to carry and swing in close terrain. The cost was paid in heat and in barrel life, because a shorter barrel overheats faster, and a modified gun sacrifices some of the range and the cooling mass the original length provided. Hanging the gun on a bungee cord bought the door gunner freedom from the weight and a wider, faster traverse. The cost was a weapon that swung loose on an elastic tether, requiring its own kind of control. The men who made these bargains understood them. They chose firepower and handiness, and accepted the heat and the wear as the price. There is something telling in the direction of all this modification. The ground crews adapted themselves to the gun, learning its habits and carrying its burdens. The special units and the air crews adapted the gun to themselves, cutting and rigging it until it matched their missions. Both responses came from the same source, a weapon whose firepower was too valuable to give up, and whose standard form was too ill-fitting to leave alone. The M60 was worth modifying precisely because it was worth keeping. Men do not take a hacksaw to a weapon they intend to throw away. They take a hacksaw to one they cannot do without. That is the quiet paradox inside the complaints. The same gun that soldiers cursed for its weight and its wire and its oven mitt was the gun they refused to abandon, the gun they reshaped rather than replaced. The frustration and the loyalty were bound together. A truly useless weapon is discarded. The M60 was cut down, wired up, hung on cords, and carried up rivers, all so that the men could keep its firepower on their side. The waterways of the Delta drove some of the sharpest adaptations. On the rivers, firefights erupted at close range and ended fast, and a boat crew needed weapons that could throw out a wall of fire in the first seconds of an ambush. The M60's belt-fed firepower was exactly what those fights demanded, and its length and weight were exactly what they did not. So the guns were cut down, stripped of what could be spared, and carried or mounted in whatever way let a crewman bring them to bear instantly. The same logic drove the reconnaissance teams that operated in small numbers far from support, who valued the firepower of a belt-fed gun and could not afford its full bulk. The helicopter door was its own world. A door gunner fired for long stretches, traversed across wide arcs, and worked in a blast of wind and noise with the ground wheeling below. The bungee cord that took the gun's weight let him swing it freely, and the wired-on ration kept the belt feeding as the aircraft banked and turned. The purpose-built M60D, with its spade grips and pintle mount, formalized what the crews had improvised, and it became a standard fitting on transport and gunship helicopters alike. In every one of these roles, the pattern held. The men took a gun built for the rifle squad and remade it for a fight the designers had not pictured, trading range and cooling and control for the handiness their mission required, and accepting the bill because the firepower was worth it. The gun had broken out of its assigned role in the hands of the men who used it. It was about to break out of reality altogether, in the hands of a film industry that would make it the most famous machine gun in the world and, in doing so, would tell a story about the weapon that its own gunners would barely recognize. Those two escapes stood at opposite ends of the truth. The men in the field cut the gun down to survive with it. The men behind the camera built it up into something no one could survive against. Chapter 10. Hollywood picks up the pig. On the screen, the M60 became invincible. One man, no crew, no tripod, a belt swinging free, and no consequence for any of it. The image had a specific home. In the film that introduced the character of John Rambo, released in 1982, the M60 was the weapon of the climactic rampage, carried and fired by a single man on the move. In the 1985 sequel, the hero returned with a lightened version of the gun, the M60E3, and the picture was completed. A lone figure walking into fire, the machine gun held at the hip, the belt of ammunition trailing across his body, the enemy falling before him. That image did more to fix the M60 in the public mind than any specification ever could. For millions of people who would never see the real weapon, the M60 became the gun the hero carried alone. Everything about that picture ran against the gun's nature, and the contrast is where the honest history lives. The M60 was a crew-served weapon. It was designed to be fed by an assistant gunner and supplied by a squad, fired from a bipod or a tripod, aimed with sights, and managed in disciplined bursts. The screen erased all of that. It removed the crew, removed the mount, removed the ammunition problem, and removed the recoil that a 23-pound automatic weapon generates. What remained was pure image, a man and a gun, and an endless belt. The most persistent myth the films planted was the effectiveness of firing the gun from the hip. On screen, the hero hip fires the M60 with one or two hands and hits everything. Firearms experts who have examined the technique are direct about it. Firing a weapon like the M60 effectively from the hip is not realistic. The gun is heavy. It fires a powerful cartridge on full automatic only, and without a shoulder, a bipod, or a mount, the muzzle climbs and the fire scatters. A real gunner who tried to fight that way would waste his ammunition and hit little. The hip-fire image is cinema, not marksmanship, and the record is clear that the technique does not work as shown. There is a reason the myth felt true, and naming it is fairer than simply debunking it. The M60 looks the part. It is large and belt-fed, and it produces a visible, dramatic volume of fire. A belt of ammunition across the chest reads instantly as power. The gun's real firepower, the thing that made a squad grateful to have it, is genuine, and the films simply detached that firepower from every limit that governed it in the field. The myth felt true because it was built on a true foundation, the gun's real capacity for fire, with the costs edited out. Cinema kept the awe and cut the weight, the crew, the maintenance, and the recoil. The trade-off in this chapter is not mechanical but reputational, and it cut both ways. The films gave the M60 a fame that no other machine gun of its generation enjoyed. That fame kept the gun in the public eye, made it instantly recognizable, and turned a flawed service weapon into a cultural fixture. That was the advantage, and it was real. The cost was a public understanding of the weapon that was almost entirely wrong. The gun the world came to know, the invincible one-man weapon of unlimited ammunition and no consequences, bore little resemblance to the wired-together, oven-mitted, crew-fed animal the soldiers had actually carried. The fame was purchased with accuracy. The one who paid, in a sense, was the historical record, and the gunners whose real experience was overwritten by the myth. It is worth holding both the gun of the screen and the gun of the paddy in view at once, because the whole story of the M60 lives in the distance between them. The screen gun never changed a barrel, never wired its gas system, never lost its mitt, never ran dry, never jammed on a dirty belt. The paddy gun did all of those things, and it was carried, anyway, by men who knew its every fault and depended on it regardless. The screen version made the gun immortal. The paddy version made it human, a tool with limits, used by people with limits, in a place that punished both. The single hero and his machine gun became a template that reached far beyond one character. Across film and television, the M60 became the shorthand for overwhelming personal firepower, the weapon a screenwriter reached for when a scene needed one figure to dominate a battlefield alone. The gun's real silhouette, large, belt-fed, unmistakable, made it perfect for that shorthand. Audiences learned to read the sight of it as raw power, and the reading was not wrong about the firepower, only about the ease. The physics the screen ignored were the physics every real gunner obeyed. A 23-pound weapon firing a full-power cartridge on automatic generates real recoil and real muzzle climb, and controlling it requires a braced position, a shoulder, a bipod, or a mount, and disciplined bursts. Held loosely at the hip and fired in long streams, the gun would climb and scatter, and its ammunition, so casually endless on screen, would vanish in seconds at a cyclic rate near 550 rounds a minute. The belt, worn across the chest, so striking on film, gathered dirt that could jam the very gun it fed. Every glamorous detail of the screen image corresponded to a field reality that ran the opposite way. The movies did not invent the gun's power. They removed everything that power cost, and in removing the cost, they created a weapon that never existed, the M60, with no crew, no recoil, no reload, and no wire holding it together. The fame arrived, in a way, at exactly the wrong moment for accuracy. Because while the myth was hardening on movie screens, the real weapon was quietly being revised, patched, and lightened by an army that knew its faults better than any audience did. The gun the public was learning to see as perfect was the same gun the service was busy trying to fix. That effort to fix it produced a long line of variants, each one an attempt to correct what the last had missed, and together they read less like a triumph than like a decade of careful apology. Chapter 11. Every version of the same apology. The M60's list of variants reads like a series of corrections. Each new version solved one of the gun's problems and, often enough, introduced the next. The pattern started early. The first serious attempt to improve the standard gun was the M60 E1, and it went straight at the barrel problem that everyone had identified. It moved the bipod off the barrel and onto the gas cylinder tube, so that a spare barrel would no longer carry its own bipod, and it reworked related parts to make barrel changes less punishing. The engineering was sound. The variant, however, was not adopted for general issue. The improvements it carried would have to wait and reach the force piecemeal through later models, rather than arriving all at once in a fixed standard gun. The first honest attempt to correct the gun's central flaw did not become the gun the Army bought. Other variants adapted the weapon to jobs beyond the infantry squad. The M60 E2 was built to fire from inside vehicles, mounted coaxially alongside the main gun in tanks such as the M48A5 and the M60 Patton, and fired electrically rather than by hand. The M60C was configured for aircraft, fixed to mountings, and operated through hydraulic and electric controls rather than a manual trigger. The M60D was the pintle-mounted door gun, fitted with spade grips and a different sight arrangement, built for the helicopter role that crews had already improvised their way into. Each of these was the same core mechanism, dressed for a different battlefield, evidence of how far the basic design could be stretched to fill roles the original requirement had never named. The most significant infantry revision was the M60 E3, fielded in the 1980s as a lightened version of the gun. It attacked the complaint that had shadowed the weapon from its first day: the weight. It moved the bipod off the barrel and onto the receiver, added a forward hand grip, gave the barrel a carrying handle at last, and trimmed pounds from the whole package, bringing the gun down to a weight far closer to the promise the original had broken. On paper, the M60 E3 was the gun the M60 should always have been: lighter, handier, easier to carry and to change barrels on. The M60 E3 also proved that no fix is free, and its ledger is the clearest in the gun's history. The advantage was weight. Real pounds lifted off the gunner's back and real handiness added to the weapon. The cost was durability. The lighter barrel and lighter construction wore faster and could not sustain heavy fire as long as the older, heavier components had. A gun made easier to carry had become a gun that could take less punishment. The gunner who welcomed the lighter load in the march discovered its price in a long firefight, when the lighter barrel heated and wore more quickly than the heavy one it had replaced. Weight had been the complaint. Weight had also been part of what made the gun endure. Removing it solved one problem by reopening another. The corrections continued into the 1990s and beyond. The M60 E4, known in naval service as the Mark 43, gathered the accumulated improvements into a modernized weapon that served with special operations forces and others who still valued the design. Later still came the M60 E6, a further refined version, lighter than the wartime gun, with a strengthened feed and a longer receiver life, adopted by a handful of forces, including the Danish Army in 2015. Torture testing of the E6 showed reliability figures far beyond anything the original had managed, evidence that the basic design could, with enough revision, be made genuinely dependable. The gun that had been kept alive with coat hangers had a descendant that passed punishing endurance trials. There is a way to read this long line of variants as a success story, a design so sound it could be improved for half a century. There is a more honest way to read it, and it deserves the restraint the channel reserves for tidy narratives. Each variant was, at its core, a fix for something the previous version had gotten wrong. The bipod was moved because it should not have been on the barrel. The handle was added because it should have been there from the start. The weight was trimmed because it had exceeded the requirement by 5 pounds. The feed and the receiver were strengthened because the originals wore and cracked. The variant list is a record of persistent engineering, and it is also a record of a gun whose original design left a great deal to correct. The trade-off that runs through all of it is the trade-off that ran through the whole weapon. Every improvement bought something and cost something. Lighter meant less durable. Adapted for a vehicle meant useless in the hand. Modernized meant more expensive. The engineers chased the perfect balance of weight, durability, and reliability across decades of models, and each model landed on a slightly different point of the same unforgiving curve. They never fully escaped it, because the curve was written into the gun's ancestry, into the decision to build a light, general-purpose weapon that also had to endure sustained fire. The numbers attached to the later variants show how far the design could be pushed when its flaws were taken seriously. The lightened M60 E3 brought the gun down toward the weight the original requirement had named, though it paid for the reduction in barrel and component life. The M60 E4 and the Naval Mark 43 gathered years of fixes into a weapon that Special Operations Forces judged worth keeping. The M60 E6 went furthest of all. Lighter than the wartime gun, with a strengthened feed mechanism and a receiver engineered for a longer service life, it posted endurance figures in torture testing that dwarfed the original, rounds between stoppages measured in the many thousands rather than the hundreds, and it was adopted by forces including the Danish Army in 2015. The gun that had once been held together with a coat hanger had a descendant that passed some of the hardest reliability trials its makers could devise. That progress is real, and it should be credited. It also underlines the central point rather than softening it. The improvements the E6 embodied were, in large part, the correction of faults present at the beginning: weight, feed, and durability, addressed at last by decades of accumulated engineering. The design had the capacity to become excellent. It simply did not begin excellent, and the men who carried the early guns lived on the wrong side of that timeline. They fought with the version that needed the wire, while the version that needed none arrived only after their war was long over. No amount of revision, however, could stop the comparison that finally ended the M60's career. The Army did not judge the gun against its own past versions. It judged the gun against a rival, another old European design, fired side by side in a fair test. That comparison, more than any single flaw, is what retired the pig. Chapter 12. The gun that proved the idea and lost the job. The M60 won the argument it was built to make and lost the contest that came after. It proved that America needed a general-purpose machine gun, and then it handed the job to a better one. The winning argument came first, and it should not be forgotten in the shadow of the ending. When the M60 entered service, the idea of a single belt-fed weapon that could serve as both a squad's bipod gun and a company's tripod gun was, for the American infantry, unproven in its own hands. The M60 proved it. It showed that one weapon could close the old gap between the fixed Browning and the box-fed automatic rifle. It showed that a controllable rate of fire near 550 rounds a minute was more useful to a real crew than the tearing 1200 of the German gun, because a crew could feed it and a gunner could aim it. The M60 validated the general-purpose concept for the United States and taught the doctrine that would outlive the gun itself. Whatever its flaws, it settled the question of whether the concept was right. Its afterlife spread the design across the world. More than 50 nations adopted M60 variants over the decades. It was license-produced abroad, in South Korea from 1974 and in Taiwan, and it served with forces as varied as the Australian Army and the British Royal Air Force, whose Chinook crews used it. It found its way into police arsenals and, as such widely produced weapons always do, into the hands of non-state groups as well. A gun stamped out by the 250,000 does not stay within the army that ordered it. It disperses, across borders and across decades, into every role a belt-fed 7.62 gun can fill. The ending, when it came, was decided by a direct comparison. In Army trials held in the first half of the 1990s, the M60, in its improved E-series form, was fired head-to-head against the M240, the American designation for the Belgian FN mag, a general-purpose gun of the same wartime European generation. The test was not rhetorical. 50,000 rounds were fired through each weapon, and the stoppages and failures were counted. The M240 recorded roughly 2,962 mean rounds between stoppages and 6,442 mean rounds between failures. The M60 recorded roughly 846 and 1,669. The rival gun ran 3 to 4 times as far between problems. The numbers did not argue. They simply reported. That result carried a hard irony, and it is worth stating plainly rather than dramatizing. The M60 had been built from German mechanisms to answer a need the Germans had identified. It was retired in favor of another European design, the Belgian mag, which answered the same need more durably. The requirement that had launched the M60 outlived the M60. The gun had proved the need was real. and a sturdier weapon inherited the job of meeting it. The Meters 240 was heavier, and the infantry accepted the extra weight in exchange for the reliability the trials had measured. The same bargain, weight against dependability, that had shadowed the Meters 60 its entire life, now settled in the other direction. The retirement was not total, and fairness requires noting it. The lightened and modernized descendants of the gun, the Meters 60 E4 and the Mark 43 and later the E6, continued to serve where their lighter weight was worth more than the last measure of endurance, with special operations forces and with the militaries of other nations. In American infantry service, the Meters 240 replaced the pig, unit by unit, beginning with the forces that most needed reliability. But the design did not vanish. It went on, in refined form, in the hands that still valued what it offered. The gun's dispersal across the world outlasted its American frontline career by decades. Licensed production in South Korea, beginning in 1974, and in Taiwan, seeded whole regions with the design and the ability to make it. Allied forces flew and fought with it, from Australian infantry to the crews of British Royal Air Force helicopters. As the United States moved to the Meters 240, surplus Meters 60s and their parts flowed outward into the arsenals of smaller forces and, inevitably, into the hands of groups no government controlled, the ordinary fate of any weapon built by the 100,000. In the United States, the relatively small number of legally transferable Meters 60s became prized and expensive collector pieces, a civilian afterlife for a military tool. The bargain that ended the gun's infantry service deserves one last look, because it names the theme of the whole story. The Meters 240 that replaced it was heavier, and the infantry took the extra weight knowingly, in exchange for the reliability the trials had measured, 3 to 4 times the endurance between failures. It was the same trade the Meters 60 had wrestled with from its first prototype: weight against dependability, steadiness against burden, only now the Army chose the other side of it. The Meters 60 had spent its career trying to be light enough to carry and sturdy enough to trust, and had never fully managed both at once. Its successor accepted the weight and won the trust, and in doing so, it proved that the requirement the Meters 60 had been born to meet was real, permanent, and worth carrying. The verdict on the Meters 60, then, has to hold several truths at once, and the popular verdicts fail because they hold only one. The claim that the Meters 60 was simply a bad gun requires restraint. It was not. It was an effective, powerful, widely trusted weapon that gave American squads firepower they had never had in a single gun, that served through the hardest war of its era, and that proved a doctrine still in use. It was also a gun burdened by real design flaws: a broken weight promise, a badly arranged barrel, a gas system that would not stay together, a structure with a limited life, flaws its users spent years working around and its engineers spent decades correcting. Both of those descriptions are true. The gun was good enough to keep and flawed enough to replace. That is the honest measure of the weapon, and it returns to the question the whole story began with. The Meters 60 lived 2 lives, the immortal one on the screen and the burdened one in the field, and neither by itself is the truth. The truth is the trade-off between them, the firepower and the price, the fame and the record. The Army built the Meters 60 to close a gap and to lighten a load. History made it heavier than the promise, more famous than the facts, and more beloved by its enemies on film than by the men who fed it in the mud. The Meters 60 was built to be a tool. History turned it into a legend it could not live up to, and left the men who carried it to make up the difference with wire, with a ration can, and with an oven mitt. The problem never changed. An American squad needed one machine gun that could both move with the assault and sustain fire when the squad stopped, and for a long time no such gun existed in American hands. The answer was assembled rather than invented. Designers at the Army's arsenals took the operating system of a German paratrooper rifle, the FG-42, and the belt feed of a German general-purpose gun, the Meters G-42, and built them into a single weapon across a decade of prototypes, the T-44, the T-52, and the T-161. The requirement asked for 18 pounds. The gun that emerged, type classified as the Meters 60 in the late 1950s, weighed 23, and that broken promise set the tone for everything that followed. Industry turned the design into hardware by the 250,000, stamping receivers from sheet metal in plants run by Bridge Tool and Die, Inland, Sacco Defense, and Merrimont, so that a nation could arm quickly. That speed came at the price of a structure with a finite life, and the same drawings that let the gun be built fast also froze its flaws into every copy. The bipod and sight and gas system all hung on the barrel, the missing barrel handle, the gas plug that backed out, the sear that wore. Then the gun escaped its assignment. It went to Vietnam and became the pig. Heavy and hungry, fed by a whole squad and kept running with a coat hanger, a sea ration can, and an asbestos mitt. Special units cut it down for close work. Helicopter crews hung it in their doors. And a film industry lifted it out of reality entirely, put it in the hands of a single hero firing from the hip, and made it the most famous machine gun in the world, a portrait its own gunners would barely have recognized. The price was paid at every step, and it was always paid by the man carrying the gun. He carried the 5 pounds over the promise. He carried the spare barrels with their attached bipods. He wired the gas system, lost the MIT, cleared the jams, and re-zeroed after every barrel change. The firepower on the other side of the ledger was real, and he was grateful for it, and he paid for it in weight and heat and endless maintenance. The afterlife carried the design across 50 nations and into another century, in variants that each corrected the last, until a fair trial against the Belgian MAG, adopted as the Meters 240, retired the gun from American infantry service on the strength of numbers that could not be argued with. The Meters 60 had proved the need was real. A sturdier gun inherited the job of meeting it. So how do you weigh a weapon the screen made immortal against the men who carried it and could not wait to set it down? The answer is to refuse to choose between the two pictures. The immortal gun of the film and the burdened gun of the paddy are the same steel, and the truth is not one or the other but the distance between them, the firepower and its price, measured on a soldier's back. The Meters 60 was neither the invincible hero nor the worthless junk. It was a flawed, powerful, deeply human tool that did a hard job well enough to be loved and badly enough to be replaced. The army built it to lighten a load and to win an argument. History kept handing it heavier jobs, brighter fame, and longer wars, and it left the men who carried it to close the gap between the gun it was and the gun it was supposed to be.